Okay, hello everybody. Welcome back to General Chemistry 1 lecture. Today I'll be going over Quiz 8, which deals with chemical reactions, writing chemical reactions, being able to balance them, writing net ionic reactions, and etc. So by now this quiz was already due, so I have posted this video. Hopefully you did well, but writing chemical reactions is a key skill that you're going to need to have throughout the rest of this course and pretty much any other chemistry course that you take, General Chemistry 2, Organic Chemistry, any other upper level chemistry class you take, you're going to need to be able to write chemical reactions, balance them, and it's a key skill to have, especially for the remainder of this course. So our first question asks us, when the following equation is balanced, the coefficients are. So meaning, this is a typical type of question you'll see from me. When the following equation is balanced, what are the coefficients on the compounds in the equation? So we can see that aluminum nitrate is forming with sodium sulfide to form aluminum sulfide and sodium nitrate. So we need to balance this equation, meaning we need to put whole number coefficients in front of each compound to ensure that the same number of atoms of each element are, the same number of atoms of each element exist on each side. So right now, if we were to look, we would see that in aluminum nitrate, we have one aluminum atom, but in aluminum sulfide, we have two aluminum atoms. So that's not balanced. We cannot change the subscripts, but rather we can change the coefficients. So you never really want to start with oxygen when balancing the coefficients. So I always start with the non-oxygen elements. So I'm going to start with aluminum here. So I see I have two aluminum here in aluminum sulfide, and I have one aluminum in aluminum nitrate. So I'm going to put a 2 in front of the 2 for aluminum nitrate. Now, where does this take me? Well, it takes me over to the nitrate, and it points out that we're in a bit of a predicament here. We see that there's an imbalance between the nitrate and the sodium, and this in turn will affect the sulfide here. So the easiest thing to do here is to envision a number or a series of common multiples that would be able to add up to balance this equation. Now, there's no mathematical way to just, spit this out. You really just have to think about it. So I'm going to walk you through my thinking. I see here that I have two sodium atoms. If I was to put a 2 in front of here, that would not fix my nitrate problem. If I put a 3 in front of here, right, that would mean that I would need 3 sodium, but how could I get 3 sodium on the left-hand side if I have a superscript of 2? But what I could do, a subscript of 2 rather, but what I could do with that same logic is put a 6 in front of here. What does that do? Well, that means that I can put a 3 in front of here to balance the sodium because of that 2 there. So now if we count the atoms on each side, I have 2 aluminum, I have 6 nitrate, I have 6 sodium, and I have 3 sulfur. So let's verify that that's the same on the other side. I have 2 aluminum, I have 3 sulfide or sulfur, I have, let's make this sodium, I have 6 sodium, and I have 6 nitrate. So like I suspected, that has fixed our problem, and that has balanced our equation. So you could see how I walked you through the logic there. I wanted to fix the sodium. I wasn't thinking about the oxygen. You don't want to think about the oxygen because that can tend to get you into trouble, okay? Because we'll especially talk about oxygen when we deal with redox reactions. But in the meantime, you don't want to deal with the oxygen. So I was dealing with the sodium, and I saw I had 2 here. And I wanted to put a 2 in front of here, but I saw that if I did that, I wouldn't fix my nitrate problem. So what was another common multiple that I could fix? And in order to fix that problem, and 3 and 6 would do that. So the answer here, or my coefficients rather, are 2, 3, 1, and 6 going across horizontally. So the answer here would be A. So for the rest of the problems, I won't go through and write, how many atoms on each side. You can just trust that I've done it correctly. But if this helps you, feel free to do that, but just know it will take up some time on your exam. So question 2 says, if you write the following equation, if you rewrite the following word equation as a balanced chemical equation, what will be the coefficient symbol for iodine? So let's do that. This is a common question. Let's just put these words into chemicals. So bromine is Br, but be careful, it's Br2 because it's diatomic. Potassium has a +1 charge. Iodine also has a +1 charge, so it's Ki. Potassium bromide is the same deal. Potassium has a +1 charge. Bromine has a -1 charge. And iodine is elemental N. It is diatomic as well. So we put the 2 there. Now, is this balanced? Well, we have the diatomic scenario here. So easiest way when you have that diatomic scenario is I'm just going to put a 2 in front of each compound. So now I have 2 potassium, 2 iodine, 2 iodine, bromine. So the question asks, what's the coefficient and symbol for iodine? Well, that would be right here. And it looks like we just have a coefficient of 1, so it would just be in its elemental form, iodine. So the answer here would be D. Question 3 says that aluminum chloride and bubbles of hydrogen gas are produced when metallic aluminum is placed in hydrochloric acid. What's the balanced equation for this reaction? So we are told that when metallic aluminum, or rather aluminum in its metallic state or elemental state, is placed in hydrochloric acid, we get aluminum chloride. Now this is where you got to be able to, write your ionic compounds, but aluminum has a +1 charge. Chlorine has a -1 charge, so I'm going to need 3 chlorine. And bubbles of hydrogen gas are produced, meaning hydrogen in its elemental form, diatomic gas, so H2. So this is our balanced equation. So, this is our unbalanced equation. We now need to balance this equation. So just looking here, once again, I want to start with the element that does not have any oxygen, so we don't have to worry about oxygen here. Let's look at chlorine, rather. We have 3 chlorine here and 0 chlorine here. Now, if I put a 3 in front of here, how am I going to get that hydrogen to 3? So we haven't encountered that same 3 and 6 problem that we encountered above. So if I put a 3 in front of this hydrogen, I put a 2 in front of here, then I am left with 6 hydrogen, 6 chlorine, and 2 aluminum. So that 3, 6, and 2 is a common multiple problem that you're going to encounter, especially when you're dealing with a subscript of 2. So we have 2 aluminum here, 2 aluminum, 2 aluminum. 6 hydrogen, 3 times 2, 6 hydrogen. 6 chlorine, 2 times 3, 6 chlorine. So the answer here, just looking here, looks like it should be B. So just be careful when you're balancing. Sometimes when students are first doing this for the first time, they get really stumped and the numbers just don't come to them, and that's okay. Just the more you practice, the more the numbers will come to you, and the quicker you'll be able to do this. So number 4, let me zoom in a little bit here. Number 4 is a conceptual. It says chemical equations. A, describe chemical reactions. To show how to write chemical formulas. Okay, so it doesn't show how to write chemical formulas. Does it give directions for naming chemical compounds? No. Does it describe only biological changes? No. Does it always include gaseous substances? No. But it always describes chemical reactions. Equations describe chemical reactions. So the answer here would be A. Number 5 says to write a balanced chemical equation for the combination reaction, okay, type of reaction that we need to recognize that takes place when iron 3 oxide is formed from its constituent elements. So another word for a combination reaction is a synthesis reaction, meaning we're taking two things and we're forming one. So that could be represented with letters as A plus B, and we get AB. Iron 3 oxide. So I'm just going to write the formula, how to write your ionic compounds. If we're forming iron 3 oxide, what are our constituent elements? Well, it would have to be iron and oxygen gas, right? Now, looking here at our options, you guys got lucky because I only gave you one option that includes diatomic oxygen, which is the correct choice. So our answer choice has to be C, but let's understand why. We have encountered a scenario here where we have 2 oxygen and 2 iron and 3 oxygen. The only way to balance this is once again to make this oxygen 6. So I'm going to put a 2 in front of here. That will make the oxygen 6. In turn, I'll have to put a 3 in front of this oxygen to make it 6. But in turn, I'm getting 4 iron because 2 times 2 is 4. So I get 4 total iron on the left. So that's how you balance that. All right, now we're moving into reactions in solution. Number 6 asks, which of the following ions will never form a precipitate? So for this, you're going to need to look at your solubility table. I'm not asking you to memorize the solubility table. I'm simply asking you to be able to navigate the solubility table. However, it doesn't hurt to be comfortable and, sometimes just remember, hey, this element or ion never forms a precipitate. But if you were to go through your solubility table, you would find that potassium always forms an aqueous solution. It never forms a solid. So the answer here would be A. So you could verify that by going through, wow, why did it do that? That is strange. Let's see here. Whoops. Delete. There we go. Okay. Like I was saying, you would find that if you went to your solubility table, that potassium never forms a precipitate or a solid. It always forms aqueous solutions when mixed with anything. So you can see there are some other ions that do the same thing, but really this is a question not based on memorization, but based on the fact that I know that you can navigate the solubility table. Number 7 asks for the balanced net ionic equation for the precipitation of calcium carbonate when aqueous solutions of sodium carbonate and calcium chloride are mixed. So for this, you will need your solubility table because we need to identify whether the compounds are a solid or a liquid or aqueous in the start because that's important for the net ionic. So first, let's write the balanced equation. So we're mixing sodium carbonate. Now, sodium carbonate, if you go to periodic table, is an aqueous substance. And we're mixing that with calcium chloride, which is also aqueous. And our products are going to be calcium carbonate. Now, calcium carbonate's a solid. That's chalk, by the way. And let's see here, sodium chloride. And sodium chloride, as you know, is table salt. And that is also aqueous. So let's make this a little bit cleaner down here and write it a little bit smaller. Sodium carbonate, aqueous, plus calcium chloride, aqueous, gives us calcium carbonate, solid, and sodium chloride, aqueous. So this is the balanced molecular equation. Let's write the balanced total ionic equation. So separate the aqueous substances into ions. So this is an aqueous substance, so we can say we have 2 sodium ions plus a carbonate ion plus a calcium ion plus 2 chlorine ions, and we get the solid calcium carbonate. Solids don't break apart in solution. And we get sodium ions and chlorine ions, because remember, sodium chloride is aqueous. So the net ionic equation asks us to remove what we call spectator ions. Those are ions that are present on both sides of the equation that cancel out. So in this case, that would be the sodium, because that sodium cancels here. That would be the chlorine, because that chlorine cancels here, and these should have 2's in front of them, because this is balanced when it has a 2. And that is the only thing, because the calcium carbonate doesn't break apart. So our net ionic equation would be the calcium ion plus the carbonate ion to form solid calcium carbonate, because the solids never break apart, so the ions never cancel. So the answer here would be D. Sorry for a little bit of a crammed space here, but just remember to write your balanced total molecular equation, your total ionic, and then you cancel out your spectator ions. So number 8 asks that which of the following solutions, when added to a solution of sodium sulfate, would form a precipitate. So we are going to see that when silver, potassium, and calcium are added to the sulfate, remember, because it's a double displacement reaction, 2 things are going to swap partners, so that these ions, these cations, are going to form with sulfate. Would they form a precipitate? So you're going to look at your solubility table. So let's look at first at silver sulfate. Silver sulfate would form a solid. So this one would form a precipitate. Potassium sulfate, well, we just talked about potassium. It never forms a precipitate. It always is aqueous. So this one would be aqueous. And calcium tends to always be a solid, but to double check, we would look at our solubility table, and we would see that calcium sulfate is a solid. So which would form a precipitate? Well, it would be 1 and 3 only. Number 9 asks us for a combustion reaction, the complete combustion of which of the following produces carbon dioxide and water. And for a combustion reaction to take place, we need some hydrocarbon here. A hydrocarbon meaning a compound that consists of carbon and hydrogen plus oxygen gas, and we will form carbon dioxide and water. So in order for this to take place, we need a hydrocarbon, and the only hydrocarbon here is C8H8. So that would be our answer. And number 10 says a blank reaction forms one product from 2 reactants. One product from 2 reactants, okay. So if we have one product from 2 reactants, we're basically saying A plus B gives us one product, AB. Well, what we call this is a synthesis reaction, or we could also call it a combination reaction. So it could also be combination reaction. It could also be a combination reaction, but here it's a synthesis reaction A.